What I wanted to talk about today is a subject that's been all over the news and social media, I think non-stop for the last 2 years, is how artificial intelligence tools like ChatGPT and AI in general affect the day-to-day work in software engineering. Frankly speaking, to many of us, these pace of innovations have given us a bit of anxiety about what the profession is going to look like in the near future. And this is something I want to explore in this presentation and attempt to discover how AI tools are going to influence software engineering. But in order to understand how the current trends are going to impact the profession in the future, we have to do a bit of time travel, go to the past, and try to look at what the profession used to be way before. And originally, when we think about the word computer, the meaning of the word computer or computing, it used to be done manually. It was a person, usually a woman, performing mathematical calculations. It was a very popular profession back in 30s, 40s, 50s, and a great career option for many people who were good at math at school. But it was inefficient. It required a lot of human labor. And eventually, as technology was evolving, we started automating things. We first had the primitive computers using punch cards, very close to hardware level of coding. Then went to assembly and started increasing the abstraction level with every iteration, going from assembly to C, then introducing managed memory languages, though here I guess managed memory languages actually came before C, but I guess C is a good example of this, kind of like a closer to hardware language, which is still has a bit of abstraction over working with hardware on the lower level. All the way to languages like Java or any other runtimes like .NET, where you're very abstracted from the underlying hardware. You're using a VM, and your memory is managed so that you don't really have to think about the hardware that your system is running on. And this allows you to be more productive, allows you to focus on the business domain more so than underlying technology constraints of your platform, or even in case of Java or any kind of portable languages, or for those of us who are web developers, we especially like it since we can ship to any browser. Again, moving away from platform-specific constraints and working on specific business requirements. And in parallel, as languages were developing, development tooling was also evolving. In late 90s, early 2000s, we got really clever autocompletion. Syntax highlighting was invented even before that. And from some of the recent developments, we got Copilot, which is AI-powered autocomplete, basically a natural development of the IntelliSense idea. And all the way to the current generation of AI-native development tools that generate code for you. I think they really started emerging maybe over the last 12 months, and we got the first taste of how such tools could work with the first introduction of ChatGPT 2 years ago. And when you think about how quickly this tooling is developing, 2 years ago is not that long ago, and yet the difference between the first versions of ChatGPT and what we have now is enormous. And so, reflecting on the history of computing and how tooling and technology are evolving, we can see a couple of patterns where technology evolves towards increased automation, increased level of abstraction, and increased intelligence of the tools and languages you're using. We're moving from low-level details, understanding the hardware, to manipulating a lot higher-level constructs, dealing with more abstract problem solving in the context of the business domain. More automation. I don't manage memory when I work on my day-to-day work. You probably don't have to deal with CPU registers or low-level, unless your job requires that, but you're writing some kind of drivers. But again, you're very abstracted from the lower-level hardware. Intelligence, incorporating machine learning and any kind of algorithmic programming enhancements to make you more productive, to work on more sophisticated business-focused solutions without, again, spending too much mental capacity on the problems that the machine is better at doing it. And finally, collaboration. High-level programming languages made programming more accessible, easier to a lot more people. It's easier to get started, it's easier to get moving, and it's easier to communicate with people who might not be that familiar with the domain and still have a productive conversation about how to make your system better. And given these constraints, we can think about how AI is going to affect that and how the profession might change in the near future. I compare it to being a builder versus being an architect. When you're a builder, you have to be really proficient with the tools that you use on a daily basis. In the real physical world, that'll be a hammer, some kind of power tools. In our equivalents, it would be your Reacts, Flutters, Pythons, whatever frameworks you use at any given time. You have to be very proficient with your IDs, debugging and testing, and know your traditional data structures and algorithms to be able to identify those common problems, common patterns, and apply them over and over again. With AI, things change slightly. AI can automate the large part of the things on the left, leaving you time and focus to work on things on the right. So you, instead of dealing with low-level constructs, with small syntactic challenges you might encounter working on a given framework or language, you start dealing with high-level abstractions and problem solving. And that's where domain expertise becomes a lot more important. Not only you have to be a programmer or have to have a software engineering background, but you have to be really proficient in the domain that you're working in. Finance, mining, healthcare. You become a lot more valuable by being able to apply technology to a specific domain. You become a lot more desirable as an employee, as a person in this architect-driven world when you have end-to-end testing expertise, ability to build things from start to finish, working closely with people from the business. And things like system design and architecture. Again, soft skills, communications, explaining your decisions. So things less lead code and more communication. If we break it down a bit further, we can put the kind of things that developers and software engineers do these days on the right and classify them as either low-value and high-value skills. So ability to write code from your memory correctly in 10 programming languages and configure your YAML files and JSON, some kind of JSON configurations for your CI/CD pipelines, it's becoming less relevant. An AI system, ChatGPT, Gemini, those systems can generate those scripts almost instantaneously and memorize thousands of lines of the documentation. So yes, it's important and relevant to understand every single part of this chart. You have to be proficient in these things, but the value of each of these different skills changes quite a lot. And in the future, with more and more AI tools becoming available, the value, the emphasis on the job market, the emphasis in the day-to-day work will shift more up, where you have to become strategic thinker, creative problem solver, and be very empathetic to your users in order to produce software that makes real impact, rather than closing Jira tickets or being able to write an elegant React hook of some sort. Less relevant. So, given what I just showed you, let's have a look at some of the current state-of-the-art tools that are available on the market and how, within the framework that I just described, how those tools can help you to maybe automate some of your work and become more of an architect rather than a builder. First, I hope many of you tried that. Tools like Copilot, Amazon Q, or recent Xcode AI. Next step of evolution of autocomplete. You type something in your IDE or an editor, and the system attempts to analyze the context of the file or the broader repository and gives you suggestions on what are the next lines or multiple set of lines that are likely to occur after the place where you're typing. Pretty straightforward to use, very familiar to anyone who used an IDE or a tool with autocomplete. And they come in many different flavors. Originally, when Copilot came out, was originally originally GitHub owned, and then Microsoft acquired GitHub. So there was a lot of issues around who owns your code, whatever they use it for training or not. These days, you can pick a tool you like that suits you better. It can be cloud-hosted, like Copilot. It can be self-hosted on your own server, just for your company, or it can be run entirely on your machine. For example, here, I have a small LLM running entirely locally on my machine, and I can tell it, I'm just going to say hi because I don't have a keyboard, but it's really fast. It performs about as well as GPT-4, and you can run it entirely on your machine, fully private. Your code is not leaking anywhere, and you can integrate it with common popular IDEs such as IntelliJ or VS Code. So if you are not using systems like these, I highly recommend you to, because the impact on productivity is pretty phenomenal. Quantitative research studies shows that teams and people who employ such systems observe between 20 to 50% boosts in day-to-day productivity. The first study focuses on giving Copilot to 3 groups. One group was experienced developers who had access to such tool. The second group was a group of inexperienced developers or people with little coding experience who were given access to such a tool. And third group was developers who did not have that tool. And overall, developers who were already proficient with the technology were a lot faster. People with little experience had access to Copilot, were able to complete the task, even though not as fast as proficient developers, but still they got to the completion. And another study, a couple of studies from Microsoft and Accenture show, again, 8 to 20% boost in productivity, number of pull requests, number of closed issues. So there are very little reasons why you shouldn't be using an autocomplete tool like this. There are a couple of caveats and issues that people bring up every time you mention an AI-powered autocomplete. They say that tools like Copilot or any kind of AI systems can generate code that it's not particularly accurate or may contain errors, security vulnerabilities, preference APIs that don't exist, and which is fair. Such issues can happen. However, you are software engineers, you are developers, you're still expected to be able to understand the code that the system suggests to you. This system by no means automates your job. Instead, it shifts the emphasis from writing code to reading code and reviewing it. And given you are a proficient engineer and you know what you're doing, it's fairly easy for you to identify those issues and resolve them basically by hand. And plus, processes in your companies like code reviews can help you to make sure that the generated code that you're committing to your repository meets the standards and quality guidelines of your company. Next thing that people often mention is the issue of copyright. Most of these models were trained on large volumes of open source repositories. Some of them might have ambiguity regarding licensing, which is a fair complaint. But in reality, if you look at how Copilot works, it usually suggests you 1 to 2 lines of code with every suggestion. And the chance of collision with public repo is rather slim in practice. On top of that, if you're using a commercially available Copilot or AI auto-completion tool, they usually come with additional layer of safety where the tool automatically searches through a list of public repositories trying to find exact matches for the code it suggests, and that way it can exclude any copyright risky material, making it so that you only get artificial synthetic code that hasn't appeared in any other repository. So yeah, if you're not using AI-powered autocompletion in your company, please talk to your boss. The savings are real, and it's just a natural next step compared to traditional IDE autocomplete. Next, we have AI chat assistants. You may say that ChatGPT was somewhat of an AI-powered code assistant. The advantage of these tools is that you can give it a whole snippet of code, a bit of context on what you want to achieve, and it spits out the solution for you. When ChatGPT came out, it was useful for things that were limited in scope, very focused, but still it allowed developers to become a lot more productive. these days, the tools have progressed drastically, especially over the last 12 months or so. Now they can do either file-level editing or multi-file editing. They can generate UIs, unit tests. They're very sophisticated. They can keep a snapshot of your whole code base in their kind of like an internal memory, allowing them to suggest code that is specifically tailored to the repository you're working with. And just like with AI autocomplete, these tools can be cloud-hosted, they can be self-hosted, or you can run it entirely on your machine. And I'm going to show you a little demo of some of the tools that I find really impressive, and that could maybe change your perception of how far these tools have progressed. First tool is V0. V0 is developed by Vercel, the company who made Next.js, and allows you to generate self-contained UI components for your React projects. It's really, really tailored for React. You can somewhat use it for React Native, but the fact that the way how it generates code and the quality of the end results is rather impressive. For example, I can select some of the suggestions here, like generate a SaaS pricing calculator. And what the thing will do, it will evaluate my prompt, ask me some follow-up questions, but it will generate the React code on the right and show you the preview of what it looks like when you run it in the browser. Boom, we have a SaaS calculator. So if you want to launch your billion-dollar SaaS startup, I mean, this is probably a good place to start. Not only you get the code that you can pretty much immediately use, you can send it follow-up prompts, making any kind of changes that you will want to see in this project. You get the source code, and you can easily share it and deploy it on Vercel, creating a public link that allows people to access your little prototype. Or you can add it to your own project using the SHA-CN CLI, which is a UI component library, or you can download the source code. This tool is remarkably useful for internal tooling, for quick, rapid prototypes. If you want to communicate with your clients, show them how a certain thing might look like once it's ready, indispensable for doing so. In the matter of minutes, you can get a functioning web app that you can show to your clients and maybe automate certain workflow or do something. But V0 is limited to how it kind of works within the context of one React component. It's really a component builder. There are more advanced systems, such as Bolt.new, developed by a company called StartBlitz. This tool creates a container, a whole virtual environment in your browser where it can install dependencies, execute commands, and do a very similar thing to V0, but in a lot more production-ready manner. So in this example, I uploaded a screenshot of a very simple-looking landing page. Screenshot found on Google, hopefully no copyright infringement here. And let's say I tell it to replicate this landing page with React and Tailwind. If I click continue, and my Wi-Fi doesn't die, we should see that the system will attempt to analyze what's on the screenshot, create the relevant prompts, create a full-on Visual Studio Code-like instance on the right, install the necessary dependencies, and create a perfect multi-project, multi-file setup file repository, and recreate that landing page using React and Tailwind, as I said. And if you give it a minute, it will load our preview. Boom, we got our landing page. It works for any kind of web project. It can be Angular, it can be React. So you can, again, quickly and effortlessly prototype internal tools, client demos, landing pages, portfolio websites. But at the same time, it makes you think of how easy and approachable it becomes to make relatively simple things like this. So if we look at the data from a couple of case studies, teams who adopt AI solutions like this see enormous increase in their productivity. The case study between Claude and Gumroad, platform for selling digital goods online, engineers at Gumroad saw a 300% increase in their day-to-day productivity, shipping new features to production a lot faster, 4 times faster feature deployment, and again, significant reduction in context switching for engineers to answer support tickets. The system could connect to their CRM system, to their customer support system, and allow them to troubleshoot customer issues a lot faster. All these tools have APIs. All these tools are open to extension, so you can really integrate it into the day-to-day work of your company in order to get a real productivity boost. Finally, the cutting edge of this technology is AI agents. AI agents are somewhat similar to what I showed you with Bolt.new, but they're a lot more versatile. So you get an agent that can run in your CI/CD or your local environment and can do tasks on your behalf, be that editing files, executing commands, understanding images, interacting with your computer. And because it's so versatile, you can use them for a whole number of tasks, from end-to-end test automation to code-based conversion. For example, you have a legacy project in .NET Framework that you would like to convert to .NET Core. The thing can do it for you. Or JavaScript TypeScript conversion. The system is capable of mapping out your repository, going file by file, and creating a new version with modernized dependencies. Bug fixes and code review. You create a pull request, or you just run the system occasionally on your code base. It could open up a PR and make suggestions on how to fix maybe a vulnerability issue, or a small bug fix based on the GitHub issues that you might have in your repository, or as a part of code review, the thing might suggest how to make your code better. And I'm going to give you a little demo of a tool called Openhands. There was quite a bit of fuss in social media about AI agent called Delvin. Back in the day, I think it was a couple of months ago. This is open source version of Delvin. In this instance, it integrates with OpenAI O1 model. So it's really tailored for this kind of autonomous agent-like behavior. And I'm currently running it in the container, locally on my machine. So I loaded a simple React Native to-do app and given it tools to work with. So the agent can run terminal commands, it can browse the web, it can run arbitrary code in Python, and we can see the output and thinking process on the left. For example, I can ask it to update the README. I think updating the README or changelog could be a fairly realistic use case. This system can run in a headless mode, so you can run it as a part of your CI/CD or GitHub action. Then using your repository, it could then create a separate PR request or any kind of change request with a modification that you want to use it for. This is a container. So essentially the way how it works, the model is provided with a set of tools, and the model gets explanations with the system prompt. The model gets an explanation of what each of the tools do, and then some of the models are tailored for reasoning, so they can aim to use the tools to get to the solution to the problem you give them. So O1 is a set of models by OpenAI specifically tailored for this kind of problems, and it's not running on me, or is it? As you can see, the technology is not perfect. But I did test it for a few use cases. One of the use cases I tested it for is converting a legacy React Native project to using Expo, because as we know, React Native migrations are rather painful. A friend of mine used it for converting a pretty big project from CoffeeScript to TypeScript. So these tools can be useful. They require a bit of fine-tuning, figuring out the exact set of prompts to make it work. But overall, with few lines of code and a Docker container, you can get yourself an autonomous agent with like a junior developer who might need a bit of too much guidance, but regardless, it does get to the solution, and the systems are only going to get better from here. And you can self-host it entirely within your work environment so that no data would leak to any other third-party service. Or you can use hosted API keys from either AWS Azure, where the data is obviously not used for training because of their contractual restrictions. If you find out that they use your data for training, you might win a massive lawsuit. Congratulations. This is the frontier where this kind of technology is going. And returning back to the kind of skills that people need, working day-to-day as software engineers, or will need working as software engineers in the future, it brings us to an interesting conversation about hiring. Because the popular assessment methods that we use are really focused on evaluating those lower value skills rather than higher value skills. So if you're using lead code as a part of your hiring assessment, I would recommend stopping doing so, because the only thing you're evaluating is whatever person practiced lead code before your job interview and not how good that person is at any given technology. Take-home assignments, on the other hand, are not a bad idea. Keep in mind that the person is likely to use AI solutions, and there's nothing you can do about it. So make your take-home assignments a bit more difficult. Be a bit ambitious. And that way you might be able to identify candidates who are not only good at the technology you're testing, but also at using all the tools available to them to solve a problem that they're likely to encounter at the job. Live coding interviews, also another good example. As long as the problem is realistic enough, that's still a valid assessment method. You'd be testing both the strategy, communication, and ability to use those tools. And again, just like with take-home assignments, I would honestly encourage candidates to use both AI autocomplete and AI chatbots as a part of the process, because more likely than not, if not now, but a year from now, 2 years from now, your company will adopt these tools because the productivity gain is insane, and the candidate you're interviewing will be using those tools. So if you're interviewing them to see how likely they would perform well in the context that resembles the job as much as possible, please give them the context that actually resembles the job. And yeah, overall, if you summarize it, if you're trying to pick a good candidate, focus on reading and reviewing the code. You might either find your worst code base you have in your company and throw it in the candidate and ask them to code review it, or you might create a fake example. You might even use AI and prompt it to create a really, really terrible example of code and ask a candidate to refactor it, to give feedback on how that code base could be improved. That way you'd be able to tell how, in terms of strategic thinking, how good a person would be. Generally, this mindset, a person being able to pick up new technology, being able to move quickly and use all the tools available at their disposal to solve your business problems. Finally, domain-specific expertise and soft skills. It becomes, given that the hard skills are becoming easier to acquire or easier to adopt, soft skills actually become a lot harder. Like, they don't get as much of a boost as the hard skills. Plus, nothing replaces domain expertise. So if a person has some inside knowledge on how your specific industry functions, some proprietary machinery, proprietary kind of software, regulations, if you work in healthcare or banking, that's still indispensable, and the candidates who can display those domain-specific skills are ever more valuable. And to conclude, if we try to imagine where all of this is going to be going next, more autonomous agents, more natural language programming, less coding with kind of like I call them high-level programming languages, like the JavaScript, Python, whatever. But in reality, they're still programming languages. But instead, it becomes very easy to imagine where you'll be coding or solving business-specific problems using natural language. Augmented reality and VR becoming more common. Maybe we'll eventually get a cheaper version, Vision Pro. I always recall this scene from the second Iron Man movie where Tony Stark was trying to discover, I think, like a chemical element of some sort, and talking to Jarvis, AI assistant, using natural language. I think it's a fascinating example because before it looked like sci-fi. Honestly, these days, creating a UI like this is rather trivial, funny enough. So what can we see here? Holographic visualization can be done with Vision Pro. Giving natural language commands to your voice assistant can be done using our LLMs. So, as much as you can be at unease about maybe the changing face of your day-to-day work, working like Tony Stark, discovering new chemical elements doesn't sound like a bad proposition to me. You will still solve difficult problems, you will still make real-world impact, but you're going to be more of an architect than a builder. So I'm going to stop on this and open the panel to any questions.
Thanks, that was wonderful. I work in product management and I've spent probably 60 hours in V0 over the last 2 weeks.
Here we go.
And the happy medium I've kind of found is, instead of spending ages writing like a 2-page brief, I'll just give it to V0 and have a clickable prototype straight away. And then I'm not overconfident enough to think that I can code that out, so I'll hand it off to our developers. But I have noticed the moment you try and get V0 to do any kind of back-end logic or even simple things like connect to an API, bring in some data, it gets stuck in a maze full of errors. And I just want your opinion on like where you see that going.
Try Bolt. V0 is a tool specifically designed for UI and UI prototypes, and even for UI, it's component level UI. So you design one component at a time. Please do not try to design the whole product in V0. Just you're designing one isolated module or a page. If you want something more complete, use Bolt. You mentioned that you involve your developers after you have a clickable prototype. You could try to flip that on its head. Involve your developers early. There are tools that they require a bit more understanding of underlying code, maybe knowing how to scaffold the project. For example, a good tool is Cursor, if you ever use that. It's a fork of VS Code with better integration of AI. It's able to do let's see. Yeah, so you can see it basically looks like VS Code. It's able to do multi-file editing. It's able to do all the things that V0 can do, but it's not going to give you that instant preview. You'll still have to run it yourself. However, your developer can do it with you. So sit with your developer in one computer and use that for prompting, and you're going to get a lot further. So you still need your developer to polish it, to help to review what the AI generates, and that way you're going to be a lot more productive. It's fine to do a small prototype, but with V0, either assume that they are disposable or involve developer early on.
Could I just make a comment about it's a really good talk, but the points you were making about Copilot, one of the things to keep in mind with that particular tool is that the copyright issue around AI, large language models, whatever you want to call it, is still very much an unresolved legal quagmire. But the one benefit that Copilot does have going for over pretty much any other tool is that Microsoft have essentially underwritten anyone that uses Copilot that they will fight your copyright fights, if there are ever any, if you're using Copilot, which is a bit of a huge deal from a commercial perspective. But other than that, yes, the other tools like Cursor and things like that are quite good.
Absolutely. The Microsoft probably has the most robust enterprise-friendly offering out there. The legal guarantee they give is pretty good. As far as I remember, AWS offers something similar with their Amazon Q. So if you shop around, you might find terms and conditions that fit your specific organization. As I mentioned, the copyright constraints and issues you might encounter, they're very theoretical in nature. You type print, you get print hello world. Did I just violate someone's copyright? Maybe. But in reality, you're going to be dealing with 1, 2, 3 lines of code suggestions, which also going to be primarily driven by your own code base, by your own file. So yes, in theory, if you generate a large chunk of code, you might accidentally copy something from an open source repository with more restrictive license. In practice, with tools like Copilot, it's next to impossible, again, because of the additional filters that prevent that exact thing from happening. And in reality, you get small chunks of code that are generated from the combination of public database of code plus your code base. On top of that, when you ship your code, you compile and minify it. So even further, so tracing the changes, the code changes that you make back to the original source are next to impossible. If anyone's going to get in trouble, with that, is the companies who train those models. You as the end user, the chance of you having any kind of issues is next to impossible. But don't take it as legal advice. I'm not a lawyer.
I'm really interested to get your perspective. Looking forward in 5, 10, 15, 20 years' time, when these kind of tools and more advanced tools than this are ubiquitous, how is the next generation of software developers going to learn the systems thinking and the techniques that they need to double check and validate the code that these kind of tools are putting out?
That's an excellent question. And again, the value of the kind of skills they teach you in universities or coding courses changes quite a lot. In my opinion, in the future, you're unlikely to be getting education just as a software engineer. You're going to be getting more specialized education in something like healthcare software engineering or mining software engineering, something more domain specific. Having that additional part to your training that complements just hard software skills will be critically important, because that will help people to apply that creative problem thinking and strategy to the specific domain they're working in. That will help them to be more empathetic to the user problems that they might encounter in their specific industry, and overall will help them to communicate better with their stakeholders. You also ask about how we're going to train people to understand specific kind of like lower level skills. On one hand, it's like a blessing and a curse. On one hand, yes, you become a lot more lazy. You can generate something, throw it at the system, and hope for the best. At the same time, it becomes very easy to research new information, to ask the system to clarify certain moments for you. Therefore, from training standpoint, the training also becomes more accessible. So I think it just highlights the value of this kind of traditional theoretical fundamental education. So mathematics, theoretical and computer science are still ever more important. So I think mid-2010s, there was a whole explosion of coding bootcamps, of self-taught software engineers that would maybe do a short course, 6 to 12 months, learning, let's say, React or some kind of JavaScript framework, and then jumping onto the job market. Those professionals filled the gap that was in the market at that time. However, long term, if those people don't upskill themselves, don't research those lower level topics, or don't go more deeply into the underlying domains they're working in, they'll really struggle. Yeah, from training standpoint, the fundamentals are more important than ever. You have to understand why. It would be very beneficial to understand how the systems work internally. It's very beneficial to understand how computing works on the lower level. It's very returning to the architect metaphor, an architect still has to know all the constraints, all the challenges, and all the fundamentals to be able to be effective at their job, and that doesn't change.
I'd like to know if these new tools that you presented have an application in the mining industry.
Well, I don't have much experience in mining, unfortunately, so I'm not going to be the best person to answer this kind of question. If anyone here works in mining, they probably could apply their imagination, creativity, and experience to answer this kind of question better. But in my opinion, many of these tools are general purpose. So you're given kind of like a blank canvas that you can apply to your specific domain. There are APIs, there are libraries, SDKs that you can integrate with your existing tools. You can build entire new workflows, but you don't have to start with something super complex, like modifying, a major piece of software that you use for some really hardcore engineering work. You can start with basics, admin, basic task automation, converting unstructured data to structured data could yield massive results and boost your productivity quite significantly. So the benefit is there. The best example of business value of this kind of tools that I've seen so far was the company I worked in a couple of years ago. When ChatGPT just came out, we experimented with using early versions of ChatGPT for converting unstructured data to structured data. And the company's product was a SaaS product for clinical trials, where there's very complex configuration format, which was connected to your typical B2B SaaS, not even B2B SaaS, but more like a enterprise interface with lots of buttons, lots of toggles, really complex logic to configure the file. And so essentially people would get a description of a clinical trial, a long 50, 100, 200 pages document, and they needed to click buttons in the right order to configure the product to reflect what kind of clinical trials they wanted to get. And then software was basically kind of, I think, super powerful version of Google Forms. So by integrating AI into this process, we were able to convert raw clinical trial protocols into the final deliverable, basically the YAML file that was then fed into the software that was given to patients, skipping the middle step. And the time it takes to set up a trial went from months to a couple of days.
Awesome, thanks Elliot. One more round of applause if everyone doesn't mind.